Bhakare. Uh, I am a CEO of a company called Unnati Development and Training Center Private Limited, which is based out in Aurangabad and Pune as well. So we are a training company since last 23 plus years. I am a Google authorized trainer. I am a Red Hat certified instructor, and I am a SUSE certified instructor also. Delivering corporate training since last 14 plus years to different organizations probably Visa, Mercedes. So you can see some CA technologies. I have been awarded as a best Red Hat certified instructor consecutive 2 times in a row by Red Hat itself. Let's have a quick look towards the agenda. The first 2 highlights are little, you can see some stars over there. So that's not the intention, or that's not the actual agenda of the discussion, right? But I can see a couple of people are new to Kubernetes. I will try my best to take you to Kubernetes first, and then we'll talk about a snapshot scenarios, right? So yeah, we'll talk about where should I run my stuff. We'll talk about what is orchestration, why you need orchestration. Then we'll talk about volumes and persistent volumes, which is basically volumes and PV. Then we'll talk about static provisioning. Those who knows Kubernetes, they know what is the storage provisioning in terms of static. And then we'll talk about dynamic provisioning. But there is something else than this now. It is how you can take a snapshot of a volume at a Kubernetes level. So of course, you can take a snapshot at a storage level, or if it is an EBS, you can take a snapshot of it, or if it is a NetApp or NASBox, or maybe a SAN, or maybe a LUN, you can take a snapshot of it, that's okay. But that's all towards the storage end. But being a Kubernetes admin, being a DevOps admin, how I can leverage the agile way of taking the snapshots from my K8s cluster only. That's what the actual logic we will be talking about. So of course, for that we need to understand what is operators. So those, again, it's one of the hot topics. Those who are knowing Kubernetes, they know what is operators and how it is working. But yes, we'll try to discuss operators. And of course, we'll try to discuss about volume snapshots. So in volume snapshots, we'll see how it actually works. I will try my best, if time permits, to do a demo, because I have a demo ready with me. If not, I have my GitHub URL where all the things, all YAML files has been created. So you can go through it and even try to do the snapshot stuff also. Then of course, you can deploy a stateless service, right? And Kubernetes is for stateless and stateful states both, with a more managed infrastructure scenario. And compute, we all know that's a VM or a compute engine, right? So there is one thing which is missing here called, sorry? Pipeline, no?
App engine.
App engine, yes. There is something which is missing here called app engine, which is known as source to application. Right? So you don't bother about, so being a developer, you will say, hey, I don't bother about where my infra is getting deployed. So I have my Python app, or I have my Golang app, and I will just push it to, of course you can do it via pipeline, or you can use your any cloud repo to trigger and all that. That's another way of dealing with it. But yes, we have app engine also. So out of this, I will be talking about Kubernetes. I will be talking about why you need Kubernetes and what's the purpose of Kubernetes, right? Maybe again a quick question, a quick poll. How many of you are not knowing what is container? Not knowing. All of you, right? Great. Then my job is easy, so I think we'll be able to complete it on time. So we being a developer, or we being a DevOps admin, the entire disruption in IT industry is happening because of containers. I hope everyone is agreeing on that, right? Even whatever is happening, even if you see AI/ML or Vertex AI or Gen AI, right? Even if you see BARD, even if you see LLM, all these are getting deployed nowadays on the containers. The only purpose of doing that is lightweight. But as we are growing up with the containers, we need to orchestrate them. We need to manage them, right? So let's see how you orchestrate it. So I have a very simple analogy to understand what is basically orchestration. Right? Imagine a case that you have a classroom. Of course, I have intentionally put it in a black and white scenario because this example will actually relate with your school. Makes sense, right? Of course. Because this is, as of now, this is like a tuition. This like a personal tuition. Students are going to a class, they are attending the class. If no class teacher, then holiday. Simple. Even another problem is these all three class teachers are not in sync. They might not be talking to each other, they might not knowing each other, they might not know who is teaching what, how many lectures, who is teaching, nothing. Right? So we need someone, even if a new admission comes, what will happen? The first class teacher will say, no, you go to second class. The second class teacher will say, no, you go to third class. Then third will say, no, you go to out of the college. Difficult, right? That's not the way of dealing with it. So we need someone on all these three class teachers. Right? Maybe you might have guessed it already. What is that? Maybe, yeah, principal could be a little higher hierarchy. Maybe before principal. HOD, right? Probably HOD, right? So because it's a department, right? I'm considering it's a department. So you need an HOD. So point here to be noted that we are not replacing the class teachers. We are adding someone on top of these class teachers who will do a central management, who will do a load balancing of all the class teachers, and the high availability of these class teachers as well. So if one of the class teacher is not coming tomorrow, he will instruct those students to shift or to get split into remaining two classes. So of course, these students will not able to enjoy the break, right? So that's obvious. So that's what the logic behind. And you know, after this only, you can see all this analogy as in college. Before that, on which the classes are happening, these are nothing but the host, the VMs, the nodes, right? The you can say worker machines. There are different naming conventions for it, but it's one and the same. Now those might be coming from my Google Cloud instances, those might be coming from my virtual machines, those might be coming from my bare metal VMware scenario, or might be anything like from wherever I want to get it, right? So I will get those resources, that is one. On top of that, you can see students. Students are nothing like a containers. So you can replace like in one classroom there can be multiple students. In the same way, in one host there can be multiple containers running. In Kubernetes, we name it as a pod, by the way. Right? I will let you know what is pod also. But yeah, that's the student. And to manage these containers, like class teacher, we have Docker. So now we have Docker, we have Cryo, or we have a container view. So that class teacher might be a maths class teacher, might be a physics class teacher, might be a biology class teacher, that doesn't matter. But it should be a class teacher, right? So that's the logic behind all this ecosystem. That's how the analogy is. And of course, the HOD is nothing but your K8s, the Kubernetes. And now you name it as a Kubernetes cluster. So something goes wrong with this host. This K8s is capable enough to make these containers to shift it to rest of it. So you get high availability, right? Even the load distribution happens evenly, and management will happen central. So this is overall cluster management scenario or cluster orchestration scenario. That's what Kubernetes can do. That's what the Kubernetes is. And the containers here are like a students. But you know how you define that these students are coming from a same college? How you define that? Or if you see all these students, how you conclude that, oh, these are all from the same college? I'm talking about a school or college scenario. The uniform, right? So see, that is why I said the uniform is like a pod. It is basically a smallest unit which shares the namespaces. So one student can roam to different classes, right? Because he is wearing the same uniform, you get identified him as a same cluster member, right? So that's the pod. So pod is nothing but a wrapper on top of containers, right? So in Kubernetes, we name it as a pod because a pod from here can talk to a pod which is sitting here. That is why we name it as a pod, right? Now the point here is, any container or a pod logic does not save data persistently. the major issue, the major concern with containers, containerization or orchestration, both, is my data. Data is nowhere getting permanently stored. It is ephemeral. Ephemeral in nature means what? The data is there till the container runs. If you delete a container or if you delete a pod, data is gone. So to cater this issue, to solve this issue, we have a simple concept called volumes or persistent volumes. Volumes is like a directory. You simply say, okay, the container data is not permanent, fine. Go ahead and save it on my host machine. Right? You say /data on my host machine will map to my pod directory, like host path. So there are different types of it. It is also known as host path, or you have empty directory like that. So you can use volumes in that case. But we all know, as an enterprise scenario, we never store the data on a local storage. So being a Google product, being a Google Kubernetes engine product, what do you think? Where should I save my data? I should be using some disk, maybe a SSD disk, right, or a non-SSD disk, right? I should go and create 10 GB, 20 GB disk, and then I will be using that to my Kubernetes, right? That's the best solution. So that is achieved via persistent volume, PV. So PV is basically a durable storage. It is not, the geographical limitation is not till cluster. Even if your cluster is gone, your data is still there. That is PV. Why? Because you are putting outside the cluster, like a Google Drive. If your laptop got formatted, of course you log into your Gmail and get your data back, right? Simple. Because it's not on your laptop. What if I lost my laptop? Right? I can go to another device, I can simply log in with my credentials and I can get my data back. Or imagine a case that I have a USB disk. I put a data on my USB disk. If something goes wrong, I can just pull the USB out and I can secure my data. That is what the PV is. And it's independent of a pod life cycle. So what is happening with my pod, it doesn't bother out. Because it's not local. It's outside the cluster. That is what the PV is. Now there are two ways to provision this PV. One way is the static way. So you tell, this is my PV, this is where I am bringing my storage. That is static way. One is dynamic way. Let me explain that properly. See here. So a developer, a system admin, a DevOps admin creates a PVC, persistent volume claim. So a pod request for a PVC, the scope of PVC is at a namespace level. Those who are knowing Kubernetes, they know what is namespace. Namespace is like a project, is like a directory. So it is at a namespace level, that is my PVC. And PV is at a cluster level. So PV tells, or PV brings the external data to your local machine, local cluster, and then you map your pod to PVC. So pod will talk to PVC, PVC will talk to PV, PV will talk to your storage. Now in my GKE scenario, what could be this PV by the way? The disk, the cloud disk, right? The 8 GB, 10 GB disk which I will, maybe a block storage, right? It could be object storage if you want, it could be a bucket, that's fine. But ideally, if it is a it's a block storage, then you will be using a disk only. You go and provision some disk. So that could be my PV, simple. But PV also, so you being a developer, you are creating a PV first, then creating a PVC, and then mapping that PVC to the pod. This is known as static provisioning of your data. And it has four types. There are ways to provision these data. One is of course read write once. Anyone know what is these methods are? Those who are knowing Kubernetes, they might be knowing. So read write once means a node, only one node will talk to my storage at a time. That is read write. once. Excellent for my stateful application, right? Of course, stateful, not stateless. Read write many. Sorry, this one. Read write many is for stateless, because multiple nodes can talk to the storage at a time. That is read write many. Read only many, I don't need to clarify. Of course, it is just a read only. There is one more new type came called read write once per pod. There is a difference here. So this one and this one is different. By node, a node can have two replicas, and same pod are running on the same, both the pods are running on the same node. Both the pods are running on the same node, and that node is talking to my storage. That is read write once. But I want only one pod to talk to my storage. That is read write once pod. This is just came, so this is also a good method. So developer will claim PV by creating what? PVC. You are not. So this is again, you have to create a PV and PVC both, right? So this is static provisioning and this is dynamic provisioning. So here you request only saying that I need 5 GB storage in the PVC, in the persistent volume claim. That goes and provision a 5 GB disk on a cloud by default. That is something known as dynamic provisioning. And this happens. Anyone know who does this? Who goes and provisions the disk for you? Those who are knowing Kubernetes? No one? You have a storage class. We have a SC, like what type of data, what type of disk I want. Maybe a standard disk, or persistent disk, or maybe SSD disk, whatever. So we have types of disk in Google, right? So which type you want to provision, that is defined in a storage class. So according to that storage class, it will bring those storage. This is a dynamic way of getting the data or getting a block storage reserved. So here the developer will only create a PVC. No need to create a PV. This is what the dynamic provisioning is. And yeah, this is what I was talking about. Here, you are telling this type. PD-standard. So this PD-standard is already defined, or you may define like this. This will go and provision that particular data, a particular PV file. Right? So yeah, that's how the static provisioning or dynamic provisioning works. But the story doesn't end here. Another problem is, what if I have to take a snapshot? I have to take a backup of my block or volume. Maybe at a PV, right? I will take a backup of PV. And then whenever needed, I will restore it. So there are two ways to do it. Of course, can I go to Google? I have a 5 GB disk provision. I can say right click, create snapshot. Once the snapshot is created, I can restore it if I want. Simple. But that you are doing at a GCP level or at a storage level. Right? In an organization, you might not have those rights. Even you have a RBAC access of a project, being an admin, that's okay. But you may not able to access the storage, right? So how you can achieve from the K8s scenario? That you can easily do via volume snapshots. CRDs. CRDs, custom resource definition. Let's see. So for that you need an operator. By the way, let me take a pause here. Any question till this? No? Great. So operators. Operators are Kubernetes based software extensions. In a layman term, I will say a kind created by you using a custom resource. So you say kind pod, kind deployment, kind service, like that you say kind volume snapshot. So you are defining your own kind. So another disruption happening in the Kubernetes industry, because of these operators. So all service mesh, right? You might have heard about EC2, you might have heard about Helm chart, you might have heard like Snapshot. All these are operators-based scenarios nowadays. In a way, they are making our life easy. But if you don't know these things, then your life might not be the easy. Right? So the point is operators, you define your kind which runs as an application. So for your K-test, for your API server of Kubernetes, it's just an application, nothing else. And to how it works, I will show you that also one minute. So here, this is very interesting flow. So in a normal scenario, you do a kubectl command, then it goes to kube API, you define an object. So then this object will get a current state. So we all know Kubernetes has a very simple logic. Desired state and current state. It manages your desired state equal to current state. So this is my desired state, object definition. You are bringing this desired state to current state via this process. And your controller does that, right? Kube controller, which runs a control loop. So this is a manual way. But what happens in CRD then? What happens in a custom resource definition? You define a new kind here. You write a new kind. Right? Then you provide it to an operators API. One more guy added here called operator API, which talks to your controller. Now one more controller got added here called operator controller. So this block has a desired state. What is that desired state? Operator. Now this block will tell your Kubernetes that my desire is to create a new CRD. So are you getting this point? Like, and this block will go to your rest of the scenario. So that three first steps are known as CRDs, a new kind, operator API and operator controller. So this operator controller will run a control loop to make sure that my new CRD is in place. That's how the operators actually works. I can talk about operators actually more, but yeah, that's not the agenda of the scenario. But yes, this is what the operator is. Fine? And how you use this? We use it in a volume snapshots. These are supported using the CSI drivers, right? Of course, container storage interface. You need to make sure that these drivers are installed. So this is a URL which tells you about if those drivers are installed there or not. So I have just opened a tab. I will come back to this tab later. But yeah. So one is this drivers are installed or should be installed. What are the prerequisites? Of course, as I said, you need a driver to implement. Then you need to enable the snapshot feature. This slide is not applicable for GKE. Volume snapshot feature is by default installed. The CRD of a volume snapshot and the feature is by default installed and enabled in your GKE. We don't need to take care of this slide, but this slide applies to your on-prem or a non-managed Kubernetes. Okay. Then, what are the kinds in a volume snapshots? There are three major kinds. One is volume snapshot class. It's like a storage class, the SC, right? Then volume snapshot content is like a PV. Can anyone tell me why there are 2 stars here? And maybe if you are checking or if you are seeing my slides correctly, you will get the answer. But why there are 2 stars? It's like a PV, by the way, defined by administrator. Can anyone guess? You don't need to create this, by the way. When you are using a dynamic method, this got created automatically if it is your dynamic way of doing it. And that is why I have put it the star here. If it is manual, then of course you have to create it, right? Then we have volume snapshots. It's like a PVC. So you say I want to create a volume snapshot. Source will be what? PVC. Source will be PVC, which creates a new PVC for you, backup. So when I take a 2 GB snapshot, it creates another 2 GB disk, right? Same thing will happen. And yeah, this is the actual implementation of it. So pod will go to PVC, you create a snapshot, it goes and say volume snapshot, class and content. And then it gets replicated. This is my disk, this is getting replicated here. So this slide is clarifying that how my snapshot can be work or can be achieved. And to do this, these are the basic steps which I have customized for this particular session. So what you need to do is, you have to create a PVC first. Now when I say create a PVC, it's a dynamic storage, it's not a static storage. So you are creating a PVC, then create a deployment. Map the PVC to deployment, right? Then create a table, database, whatever you want, just for testing purpose. Then create a volume snapshot, class, then create a volume snapshot. Please note, there is no volume snapshot content mentioned here. Why? Because I am assuming that this is my dynamic way, not a static. Then you go and change something in a table. After taking a snapshot, try to delete a row, try to exit from a row, or try to delete a database, and try to restore the PVC. Once I restore the PVC, I should able to get my data back. If I deleted a row, that row should come back, of course. Why? Because my disk is getting backup, or backup is getting restored, sorry, right? So that's how it works, and this is the code for it. Let me show you this code. So I'm using my hotspot, and maybe due to a last curse, I'm using Vodafone mobile. So I don't know whether I will be able to do a demo or not. So that's the reason I have made this possible. So deployment. So of course, this is your deployment YAML file. Yeah. So to open a YAML file, so if you see here, let me increase the font size. So if you see this volume mount, check this. So my var-lib MySQL is mounting to which PVC? My-PVC. This is what my deployment is. And then I have a file called PVC also. Of course, it should have a storage class mentioned. Let's see. I'm not sure. It should be around a KB file, and you can see to open it how much time it is taking, right? So that's the reason I'm skipping my demo. I don't think I will be able to do a demo. It's still not opening. I can connect to your Wi-Fi. Let's hope for the best. Yeah, great. So see, this is my PVC, and here you have a storage class called standard read write once. Most of the dynamic provisioning happens on a read write once method. It does not support read write many. That is because of a CSI driver. I will show you that also. But yeah, this is my PVC. And then of course, once the PVC is done, I will go to the database, I will try to change few things to it, and then I will basically define a snapshot class. And here, this is my, you can see the kind. Please check this. This driver is what? This is a CSI driver which is already installed in your GKE. So if I could copy this, let's see. Or I will simply say GKE. I will search here, storage pd.csi. See, this one. So this is pre-installed in my case. If it is not a GKE, of course, you have to use you have to install those drivers, the supported drivers accordingly, right? So this is a list of those drivers. So yeah, I have created a snapshot class. Then of course, you have a snapshot to take. If you click on snapshot, check. So I said the snapshot class, this one, and what is the snapshot claim? So please note, it is taking a backup of my PVC. This is your this is your actual source. And once this is done, you can try to delete any data or remove or try to change anything, and then simply go ahead and restore. So there is a restore option. See. So what it does is, it is bringing your snapshot back. See, you are creating a new PVC basically. And what is the source? Volume? Snapshot. So you are telling that the backup which I took, this one. Where is the backup? Here. My snapshot. This was my backup and I am restoring it as a new PVC, and that PVC-restore is my data. Now what I need to do is, I have to edit my deployment and simply change the mapping. You saw my PVC earlier. There I will go and change it to what? PVC-restore. So this is my new or older, sorry. That's my older data. And you will see your data is back. Simple. So you are no more dependent on any of the storage administrator. You are no more dependent on any of the approvals or anything. Once you have RBAC access, you can do all this. That's how the volume snapshot feature works. So yeah, I have actually documented in the slide also, but rather than doing this way, I have put it in GitHub also. So if you want, this is my GitHub URL. You can take a screenshot of this if you want. So, or simply remember, Ashutosh Bhakare is my GitHub account. You can get it from there. So my GitHub account has a lot of scenarios like this. So you can see all the repos. Most of the repos are public there. So yeah, this is what we did already. So I'm not going to talk about this. This is how you restore the snapshot. And please note again, here also the access method is read-write once, because your dynamic provisioning does not support read-write any, right? Yeah, demo I have already done. So I'm considering that demo is done, of course, because of the almost bandwidth issue. Yeah, that's all from my end. Any questions? No? Great. So by any chance, if you want to, by any chance, if you want to connect to me, this is my LinkedIn profile. Thank you so much.